Hello dear students. Dr. Bapuji Salunkhe, Institute of Engineering and Technology, Kolhapur welcomes you all to e-learning platform. This is Science and Humanities Department. The unit which we are learning is Electricity, Magnetism and Semiconductors. The topic which we are going to discuss today is numerical based on Coulomb's inverse square law. Okay? And accordingly मीन्स कुलम्स इन्व्हर्स स्क्वेअर लॉच्या संदर्भामध्ये आपण एका सेपरेट व्हिडिओमध्ये आपण पाहिलेलं आहे, आपण तो समजून घेतलेला आहे. त्याच्या अनुषंगाने विचारले जाणारी काही न्यूमरिकलच्या संदर्भात आपण या ठिकाणी पाहणार आहोत. थोडक्यात आपण पाहून की न्यूमरिकल्सच्या आधी कुलम्स इन्व्हर्स स्क्वेअर लॉ नेमकं काय सांगतो पहा. समजा दोन चार्जेस आहेत Q1 अँड Q2, तर त्यांच्यामध्ये असणारा फोर्स ऑफ अट्रॅक्शन किंवा रिपल्शन हा नेमका कसा आहे त्याच्या संदर्भामध्ये कुलम्स इन्व्हर्स स्क्वेअर लॉ हा कमेंट करत असतो. ओके, हे आपण पाहिलेलं आहे. लेट अस गो टुवर्ड्स न्यूमेरिकल्स. ओके, द फर्स्ट न्यूमेरिकल, कॅल्क्युलेट द इलेक्ट्रिक फील्ड ॲट अ डिस्टन्स 2 मीटर फ्रॉम चार्ज ऑफ 1 × 10⁻⁶ कूलम. ओके, कॅल्क्युलेट द इलेक्ट्रिक फील्ड ॲट अ डिस्टन्स 2 मीटर फ्रॉम अ चार्ज ऑफ 1 × 10⁻⁶ कूलम. नाउ राईट डाऊन व्हॉट इज गिवन इन एन एक्झाम्पल. ओके, एक्झाम्पलमध्ये आपल्याला काय काय दिलेलं आहे ते आपण आधी सुरुवातीला आपण लिहून घेऊ. ठीक आहे. ओके, गिवन डिस्टन्स आर 2 मीटर, द चार्ज which has created an electric field around it, the value of that charge is 1 × 10⁻⁶ coulomb, and in this electric field the point from the charge situated at distance 2 meter. So we are asked to calculate the electric field at that particular point. Okay, means E is to be calculated. Now E is equal to 1/4 pi epsilon naught Q upon R square is the formula. Now epsilon naught is a permittivity of a free space. Why are we taking epsilon naught here? Because in an example not particular medium is mentioned, that's why we are considering our system is in a free space, that therefore epsilon naught is placed here. Okay, now we all know that the value for 1/4 pi epsilon naught comes out 9 × 10⁹. Okay, so the value of this particular term 1/4 pi epsilon naught is 9 × 10⁹ into the value of a charge 1 × 10⁻⁶ divided by square of a distance. If we calculate whole this expression, and this comes out as a 2 × 25 × 10⁻15, and the SI unit is volt per meter, is the electric field at that point. Okay, so this way we can solve a numerical. Second numerical, the two charges 2 microcoulomb and 16 microcoulomb are placed 40 centimeter apart in air. Calculate the force between them. So two charges are there placed in air which are separated by distance 40 centimeter, and we are asked to calculate the force between them. Okay, so this is a purely an example of Coulomb's inverse square law of electricity. Okay, same way write down which are the things given in an example. Given charge Q1, what is the magnitude of charge Q1 is 2 × 10⁻⁶. Microcoulomb, micro means 10⁻⁶ is a micro, 2 microcoulomb, and our second charge means Q2 has a magnitude 10⁻⁶, means 16 × 10⁻⁶ is the magnitude for a second charge, means Q1 is equal to 2 microcoulomb, Q2 is equal to 16 microcoulomb, R is equal to 40 centimeter, means 0.4 meter, and we have already given the information about the medium in which the system is placed. The medium is air, and that's why For air, K is equal to 1. Therefore, we are not mentioning it here, and we are asked to calculate force. Write down the formula. The formula from Coulomb's inverse square law is force is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. We all know this particular term evaluates equal to 9 into 10 raised to 9. So, F is equal to 9 into 10 raised to 9 into Q1, value of Q1, multiplied by value of Q2 divided by R square. This is R squared. And if we evaluate whole this term, it comes out 3.6 Newton, because we are asked to calculate force, and the SI unit of force is a Newton. In this way, you can calculate the force. Take care of the conversions and the formula. Okay. Take note of it, which medium is mentioned. So, example based on that medium and dielectric constant we are going to see the next. So, our next example, two charges equal in a magnitude but opposite in nature experiences a force of 103 Newton when they are placed at a distance of 10 centimeter in a medium of a permittivity 4. Calculate the charge. आपणास असं सांगण्यात आलेलं आहे की दोन चार्ज आहेत ज्यांचे मॅग्निट्यूड इक्वल आहे परंतु त्यांचं नेचर अपोजिट आहे. म्हणजेच एक पॉझिटिव्ह चार्ज आहे, एक निगेटिव्ह चार्ज आहे, आणि ते यांच्यामध्ये फोर्स ऑफ अट्रॅक्शन हा 103 न्यूटन इतका आहे. ते कसे प्लेस केले तर ते अशा मीडियम मध्ये प्लेस केलेले आहेत ज्यांची परमिटिव्हिटी 4 आहे. मीन्स व्हॅल्यू ऑफ K इज 4 and the distance between these two charges is 10 centimeter. Then calculate the charge. Okay, let us write down what is given. Given the distance between two charges is 10 centimeter, means 0.1 meter. The force of attraction between these two charges is 103 Newton. K is equal to 4. Value of K is 4 because example itself tells about the medium in which the whole system is placed. The dielectric constant for that medium is 4, and we are asked to calculate Q1 and Q2. Now, write down the Coulomb's formula. F is equal to 1 upon 4 pi K epsilon naught Q1 Q2 upon R square. Put the values in the formula. Take care of that. The value for 1 upon 4 pi epsilon naught is 9 into 10 raised to 9, and value for K is 4. So, our equation will become 9 into 10 raised to 9 upon 4 Q square upon 0.1 squared. Okay. If we evaluate, why Q square? Because we are already told in an example that the magnitude of both these charges is same. Their signs are opposite, but their magnitude are so we can write Q square. Q square becomes 4.53 into 10 raised to minus 12, and if we take square root of it, then value of charge comes out as 2.13 into 10 raised to minus 6. So, our answer is Q1 is equal to Q2 equal to Q2 into 13 into 10